So in this example, what we're doing is we're transforming essentially a cosine of y equals 2 cosine theta into the function to the right here. So on the left here, we have an amplitude of 2. The cosine has no horizontal compression, and it starts at 0. So to establish the new function in the function notation, we really should figure out the a, the b, the c, and the d of this function. So the vertical expansion here, the a value, is 4. So that means then, if we start with 2, our vertical expansion factor, we've expanded it by 2. The t value originally was 2 pi. The new t value is 2 pi, so there is no horizontal compression or expansion. The d value represents the middle line, okay, or the vertical shift. So we start in the middle, it stays in the middle, so we have no vertical shift. The c value is a horizontal shift, and that can be determined different ways, depending on how we want to do this function. So to get from the first function to the second one, we could vertically flip it, and that would just mean that the vertex goes from here to here, and there's no horizontal shift going on. Alternatively, we could say that the vertex moved to pi. Okay, so we can say that it has a plus pi shift, depending on how we want to do this. We could not flip it and shift it to pi. We can not shift it and then flip it. So in this case here, it's easier to have a horizontal shift of 0, so I'm just going to leave it at 0. So the only thing that's happened here then is it's been vertically flipped. Okay, so there's a vertical flip and a vertical expansion by 2. So those are the only 2 transformations. So my new function is going to be y is equal to negative 2 times original f of theta. There's no horizontal shift involved.